All right, today we're going to go ahead and take a look at solving a system of linear equations in two variables using the elimination method. This is a third method for solving a system of equations. Our first video looked at graphing as a solution, and we also did substitution in our second video. This is a third way to do the same thing, solve by elimination. So the elimination method starts with adding or subtracting our equations. We want to make sure our equations are in standard form, which is ax plus by equals c. And then we go ahead and add. We're adding like terms here. We're like creating columns to add up. And hopefully we'll see a variable disappear, and that's called elimination. And then we can solve. So let's take a look at our first example. Again, I want to make sure that my equations are set up in ax plus by equals c, standard form, and in this case they are. And I'm going to go ahead and make this screen a little bigger. There we go. So it's in that order. So we're going to go ahead and take a look and see, make sure I've got x terms, y's, then y's, constants, constants. Awesome. So all we're going to do is go ahead and add up our two equations, and we're going to go column by column. We're going to add up the x's. I have 2x plus a minus 2x. 2x plus a minus 2x is 0 x's. Next, we'll add up the y's. 3y plus 5y, that's 8y. And 11 plus 13 is 24. I'm going to go ahead and solve my equation for y. 0 times anything is just 0, so that's off the page. We've eliminated the x value. Awesome, that's why this is called the elimination method. And we're going to go ahead and solve by dividing by 8 on both sides, and we'll get our y to be 3. Remember, in a system, your answer is an ordered pair. So 3 is the y value of our ordered pair. Now we're going to take that 3 and go ahead and plug it in. We're going to plug it in for x, or in this case, we're going to plug it in for y in either equation. I'm going to use the top equation just because that looks, looks easy to me, so we'll try that. We have 2x plus 9 equals 11. Solve a two-step equation. We'll have 2x equals 2, and our x should be 1. We do want to go ahead and verify or check this. And you remember how to check it. We take our ordered pair and plug it into both equations to verify that it's true. So I'm going to go ahead and plug it into the first one. 2 plug in 1 plus 3 plug in 3 should equal 11. And it works. We're also going to plug it into the second equation that we have. So we're going to go ahead and take negative 2, plug in 1, plus 5, plug in 3, and it should equal 13. Negative 2 plus 15 should equal 13, and 13 equals 13. So we did verify that we got the correct answer here. And that's your elimination method. Line up your variables, stack them up, add them up. Sometimes we might need to manipulate one or both of our equations to make it a little bit easier to see. We might have to multiply one of our equations, or maybe both, by -1. And that way we can go ahead and add, and we'll end up with variables that have opposite symbols, so they eliminate. So here we go. We want it to be in ax plus by equals c form. The first one is not quite like that. I'm going to add 3y to both sides. So my first equation turns into 4x plus 3y equals 2. And my second equation was just fine. So I'm just going to rewrite it by stacking it up. Now I need one of my variables to disappear. So I'm looking for opposites. I'm looking for opposite numbers, meaning like if it's -2, the opposite of that would be +2. I want to find those, but I want to find them for x or y. So when I take a look at my x column, I have a 4x and a 5x. They're not opposites. When I take a look at the y, I have 3 and 3. Well, they're almost opposites. One of them needs to be negative. So I'm going to go ahead and multiply one of my equations, the whole thing, by -1. And you know what, I don't love working with negatives, but I'm going to go ahead and do it anyway. Let's see. We get to pick which one we want to multiply by -1. I'm going to go ahead and pick the bottom equation. It doesn't really matter. You get to choose which equation you want to multiply by -1. My top equation stays the same, so I'm just rewriting it. And my second equation turns into -5x minus 3y equals 2. So we stacked them up, and now it's time to add them up. 4x plus a -5x is -1x. 3x plus -3x, that's the 0y, that we were looking for. And 2 plus 2 is 4. A 0 times anything is just 0, so we just eliminated that variable. So our x is equal to -4. Remember, our answer is an ordered pair. So my answer for x is -4, and I'm going to take that -4 and plug it in. And I want to go back up to one of my original equations and make sure I solved correctly. You get to choose which one you want to plug it in. I'm going to go ahead and plug it into the first equation. And solve. 4 times -4 is -16. Subtract 2 on both sides. And divide by -3. Our y will be a +6. We absolutely should verify this by taking our answer, our ordered pair, and plugging it into both equations. So take a moment to take your ordered pair and plug it into both just to make sure that -4, 6 is the correct answer. Pause your video and go ahead and double check. Okay, this is your verification to check to make sure you're right. And it does work out for both equations. We get -16 equals -16 and -2 equals -2. We might have to work with fractions. We can either work with the fractions or we can eliminate the fractions. I'm going to show you how to eliminate the fractions. So I always want to make sure again that it's stacked correctly. I've got x term, I've got a y term, and then I have my constant. And I want to look at the denominator. In this case, all the denominators are 4, which is awesome. So we're going to go ahead and eliminate that bottom number, that fraction, by multiplying by 4. We're going to multiply both of these by 4. So we eliminate the need to work with the fractions. 1/4 times 4 is 1. X minus 3/4 times 4 is 3. And 4 times 7 is 28. Don't forget to multiply everything. I'm going to work with the second equation. 1/4 times 4 is 1x. 3/4 times 4 is a +3. Oop, I forgot the y in my first equation. Let me write that in. And -5 times 4 is -20. Now I've got my equations looking similar to what I'm used to. They are stacked, so we're ready to add. 1x plus 1x is 2x. My -3y plus 3y, they're opposites, so I get no y's. We've eliminated it. And 28 plus -20 is a +8. I'm going to go ahead and divide by 2, and we'll get our x to be 4. So that's part of the answer, 4. And we want the y value too. So I'm going to go ahead and work with one of the equations that I've already eliminated the fraction for. So I'm going to go ahead and work with this one here, and I'm going to plug 4 in. So I get 1 times 4 minus 3y equals 28. So this is 4 minus, whoa, oh my, 3y equals 28. Subtract 4 on both sides and divide by -3. We'll get y equals -8 for that. That's one way to go about it. The other way is to just suck it up and work with those fractions. So if I go ahead and stack my fractions up the way they are, and I'm going to go ahead and erase, if I can, I'm going to go ahead and erase that multiplied by 4 and just work with the fraction. 1/4 plus 1/4 is 2/4 x. I know I can simplify, I'll do that later. My y's cancel each other out. I've got 0 y's. And then 7 plus a -5 is going to be +2. 2/4 is the same thing as 1/2 x. My y's cancel out, equal 2. Multiply by the reciprocal everywhere, and we get our x to be 4, which is the same thing we got when we eliminated the fraction. So we know we're on the right track. And then I just have to take the 4 and plug it in and solve. So I'm going to plug it into the second equation since I can see that on my board here. So I'm going to say 1/4 times 4 plus 3/4 y equals -5. 1/4 of 4 is 1. Subtract 1 on both sides. And then I'm going to go ahead and multiply by the reciprocal, which is 4/3. My 4/3, 3/4 cancel out. -6 times 4 is -24. And when I divide that by 3, I get my y to be 8. And it should be -8 because I've got that -24. Let me write that better. That's pretty messy. Y equals -8, which is the same. So you can choose. You either work with a fraction or you let the fraction go, eliminate it, and then solve by elimination. We've got a few practice problems here that we'll go ahead and take a look at. So go ahead and try your best at these, and then we'll check our answers. Okay, we'll take a look at our answers here for letter A. We just had to, they were already stacked, so all we had to do is add. We get 1, 6. For letter B, we had to rearrange, so we had to restack and then add. We get -3, 29. For letter C, I rearranged the first equation here. And then my second equation, I went ahead and multiplied by -1 so I could have opposite x's. I just crossed that second equation out so I could see what it looked like after being multiplied by -1. And then I went ahead and solved, and I got 2, -3. Our last one, letter D, was a fraction. And I chose to eliminate the fraction. I don't want to deal with these 4/5, 1/5, 2/5 things. So I multiplied everything by 5. And I got my 2 equations here. And then I didn't have to multiply anything by -1. I was just able to add them up. I get my y to be 40, and when I plug my y in, I do end up with my x being a negative fraction. And that's okay, because we're going to go ahead and divide by -4 on both sides. We get 10 over -4. That simplifies to -5/2. So sometimes when you do this elimination method or substitution or graphing, you are going to end up with a fraction in your ordered pair, and that's perfectly fine. That's your elimination method. So let's take a look at our summary. We can graph, we can substitute, or we can try this new method of elimination. In elimination, what we're doing is aligning our like terms. So we're stacking x, y, and then constant. We might have to multiply a term if necessary by -1 so that we create those opposites in the x's or the y's. And then we add them up. We solve for the variable that we did not eliminate and then substitute back in to get the other variable. Check, 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 check.